afternoon. I think most of the Queensland contingent know who I am and the hospitals in our remit, but here in Metro North, we have hospitals such as Royal Brisbane and Women's Hospital, the Prince Charles Hospital, Redcliffe, Caboolture, and a range of community facilities underneath us. So when we pulled some numbers together recently, we have about 550,000 square metres of hospital. And I was thinking back to Blake's talk this morning, talking about 2 million, so we're over a quarter of the size of New Zealand in floor area. So I think we are the largest HHS in Queensland, if not Australia, with about, I'm going to say about 2,200 beds, so we are a very large service. Over the last few years, through things like COVID, and more recently, we've had a number of, we'll call them aspergillus outbreaks in different areas. There's a lot of new terminology that I'm learning as an engineer. Aspergillus, Aspergillus terraeus, for those that know it, Lamentaspora prolificans. I'm getting really good at these because I've had to say them so many times, and there's a whole heap of other bugs out there, bacteria out there that we still don't know much about. Spell it? No, forget that. So look, this is coming from an engineering perspective. It was a presentation that Dr. Crispin Helsowitz, for those who know him up here, is an infection control, infectious disease director. He asked me to talk at a air quality session that he was holding last year. And when he first reached out to me, he said, "Oh, there's not much I can talk about, like, we're just the engineering side of it." But the more I got into it, the more I realised the value that we can add to try and minimise any infections to our staff, our patients, and keep people safe, which is, at the end of the day, what we're here for. So a couple of things that I'm going to talk about here. I'll provide a very brief overview of the HVAC system. I probably don't need to explain too much to you guys. Hopefully you will all know the background to it. Talk about a few concepts that we went through using a number of our suppliers and internal staff around airflow mapping. Talk a little bit about air sampling, some of the good things that we find and some of the challenges that we're having with it as well. Number of air quality improvement measures. Talk about the environment, which does play a big part of the challenge that we have in front of us, and a number of treatment options that we've explored. So a lot of people will know we have the large chilled water networks in our hospitals. You can see there about a dozen cooling towers sitting on top of one of our buildings. Left-hand side, one of the chillers. And on the right-hand side there, an air handling unit. So we often talk about AHUs, but when we're talking to infectious control people, they don't know what these terms are. They kind of make things up. We had a doctor try and tell us that we were getting Legionella coming out of the water drip from a closed-loop cold water network. It's like, yeah, no, I don't think so. More likely to get it out of the cooling towers, but we do obviously treat those in accordance with legislation. So very much talking about these big, large chilled water networks. I couldn't find a decent picture online, so I actually developed one myself. So these are my childhood skills, just basically depicting the air handling unit. So everyone knows we've got a big fan in the middle that's pushing air through. We've got the mixing plenum, we have filters, the cooling coil, and in some instances we have the UV light sterilisation, not across the board, but certainly in some areas. And then we pump air out into the wards, the clinical areas, the office areas. Different components in the air handling unit. That's a typical one that we have at one of our larger hospitals there in the middle. You can see all the supply ductwork, bag filters of different types. We got the fan, and we got the, there's a picture there of UV coil sterilisation as well. When we start looking at how the air gets from the air handling unit into the wards, we have a very complex mix of ductwork, generally a lot of it fixed, but we also have the flexible ductwork as well, feeding out through your air supply registers. So again, this is stuff that we should all know about, but when you're trying to chase down particularly a mould issue, it can be quite problematic trying to identify where that source is coming from, and often you need to start at one point, generally your air handling unit, work your way out to find out where the challenges are. During the early days, particularly COVID, we did a lot of airflow mapping, what we call airflow mapping. Essentially this here is a ward that we set up during the COVID period to run in negative flow. I think we ended up pulling about minus 15 pascals out of it just by manipulating the BMS and the exhaust system. But what we wanted to do is really depict where the air was going so that the clinical people had a good understanding of what was happening in those areas. We did have an example, everyone remember the hotel in the hospital concept that came out in the early days? So we had two of those hospitals. That was fun. We found that one of the infection control wards had 16 rooms in it. Half of those were negative pressure, the other half were positive pressure. Clinically, they didn't understand the difference between the two. So what we ended up finding out in talking to the infection control people is that the negative pressure rooms were all good. However, the positive pressure rooms had a register over the top of the room, basically pushing all the air out onto the area where the nursing staff were donning and doffing. Probably not ideal, so we did a lot of work in that space, and that's where these airflow map concepts came from. This is another one. This is an ICU in one of our hospitals. You see the yellow lines there are the negative pressure rooms, so again, they're all good. They'd been recently upgraded, so they were pulling both the minus 15 and minus 30 pascals, so they were great. But the air from the remainder of the ward was pushing out towards the front doors, again, where they were doing their donning and doffing, so again, not ideal. And more recently, chasing Lamentaspora through one of our hospitals after a couple of clinical incidents, we were really struggling to understand that complex mix of fixed ductwork, flexibles, where the IHEAs were located, which zones they were coming off. So we actually sat down with all the mechanical drawings and went through them in a lot of detail, and we mapped out through all of our floors which IHEAs, which zones were feeding which areas. And it was actually quite surprising that we found a couple of fan core units that we didn't know about at the time, which were potentially contributing to some of the clinical issues that we were having at the time. So again, another very useful tool there. For those in Queensland, actually no, this is a national, the Australian Health Facility Guidelines. I think everyone's familiar with them. They've got some really good literature in there, particularly around negative pressure rooms. I think everyone's familiar with these tables, the minus 15, minus 30. At the moment in Metro North, I don't believe, unless Caboolture has, we don't have anything that runs with the dual pressure differential. Everything was designed back in the late 90s. So we've only got a 15 Pascal step through our areas currently, and trying to retrofit those areas is next to impossible, as you would all know. But some really good guidance there when you're thinking about your negative pressure in your isolation rooms. Air sampling is a tool that we have been using a lot of. For me as an engineer, it's really good to give me an idea that, yes, we've got a problem here and we need to do something more about it. It also indicates how bad or how severe the problem is. When I talk to infection control and clinical people, a lot of them don't understand the value of air sampling, and even to the point where they say, oh, why did we do that? It doesn't tell us anything. It tells me a lot. It tells me a lot. It tells me if we got aspergillus in the area, okay, yep, we got a problem. But aspergillus is everywhere. Probably one of the big things that we find here is that when we take the air sampling in the clinical areas, we also take an outside air sample. That tells me that our filtration is working, which is a good sign. It also tells us if there's problems in those areas, and where there are problems we can then investigate further. There's a couple of examples up there. There are no standards on air quality anywhere, so I know there's a lot of talk around the broader community about this. Some really good conversations going on. So this company that we use developed their own guidelines. It's indicative only, but it does give us a good representation of what's happening in those areas. So some air results there from two of our buildings. One was a clinical building on the left-hand side there. The other's a disused building, and you can see some of the numbers there are actually quite frightening, particularly when your lowest level is less than 400 fungal spores per cubic metre. So again, yeah, just a really good tool for us to use to understand where the problems are. Some of the systems that we have to control that air quality, obviously everyone's familiar with the filters. Generally in Queensland Health, they recommend that we have F8 filters in our wards. Does everyone here that looks after the HVAC system, do you know what size filters you have in your wards and your clinical areas? Yeah, but does everyone? Very important to know. We actually found a couple of our hospitals were still using F5 filters at the time, so we've had to take steps to upgrade those. Your HEPA filters, obviously common in your operating theatres, some of your negative pressure rooms, etc. Coil UV's been very, very beneficial. It is only point of use, but it does keep the coil clean, and it stops that mould growth or build up in that damp area. It does save you a lot of time and a lot of money in coil cleaning as you move forward. So if you haven't got UV on your coils, I do strongly recommend it. It's not expensive either. It's quite cheap to retrofit it, so you just need to run a bit of power to it, a couple $100 for the install, away you go. Replace the lamps every 2 years, so it is very beneficial to have if you don't have those already. Back in the COVID days, we did a bit of work on bio walls. For those that don't know, I think I've got a picture here shortly, so I'll go into that in a moment. We've had a look at some air treatment, and we've also done some work with bound around the plasma shield as well. I think everyone's familiar with this chart. So we were in some areas running F5 filters, having up to a 98% efficiency there. Everyone's recommending F8s up to that 99.9% efficiency. So really useful tool is to understand what filters you got and how much of that contaminants are you taking out of your airflow system through the air handling unit. So this is the Queensland version of the Australian Health Facility Guidelines. We call it up here the Capital Infrastructure Requirements, and I think other states have their own version of this. I recall looking many years at TS18, which is the New South Wales version, if that's still around. But you can see in here where the recommendations are around the filter efficiency, F8s, HEPA in the isolation rooms. You can also see some stuff in here about relative humidity, so they do make some recommendations about that, which I'll talk about in a little bit as well. I think everyone's familiar with HEPA filters, so generally sitting above your operating tables in your theatres. And on the bottom right-hand side, there's one of our portable units. So we have a number of those that we can deploy into areas where we have critical patients quite quickly. The coil UVC, again, quite simple to install. The one in the middle there, very useful. The one on the right, maybe not so much. Then we have the bio wall. So again, another product that we trialled, installed. At this time, even though we have gone down this path and we've got a couple of these units, I can't talk about how well or how efficient they've worked. We don't have a lot of data on it, so something I'm keen to explore a bit more about to understand their true value. But essentially, the install is in the return supply duct, and it's been sized so that it basically kills 99.99% of anything that passes through it. Again, really useful during COVID because when you got your spill fans on, you're effectively dumping all of your air outside, so we're not pushing contaminants out into the environment. Air sanitisation, so everyone out there's got an air sanitiser. Everyone will tell you it's the best on the market. We've trialled a few. There's a couple that have been quite successful. So you can see there what they call an LED troffer. Essentially, it sucks the air in, puts it through a UV light filter, pushes it back out again. Does it work? Yeah. Is it one of the best options out there? Maybe, maybe not. The other unit that we've trialled there is, and I won't talk about the brand, but effectively it's a hydroxyl generator. And the way that they sell it is that basically it's putting sunshine, so it has the same effect as sunshine on the environment. So we've been trialling these and we've actually had some really good success with them. You can see on this photo here, there's one up in the top right-hand corner. So the installation is basically a GPO, a couple of screws in the wall, and away you go. But we've had some success with those. I'm not going to mention the name of this one, but I'm sure if you wanted to have another chat with Ben, you're more than welcome to. So we've done a trial of this through the company and through the Adelaide University, and I think Stantec's been involved. So we really wanted to trial this to see how effective it was, and whether it's worth the value for money that we have. We're down to a couple of minutes. Yep, okay. For those that haven't seen it, the blue line there was the pre-install filtration rates. So while we were talking about 98, 99% filtration rates on your F8s, we were getting between 20 and 50%. Was that the filters, or did we have some bypass happening there? I don't think we'll ever find out, but certainly if we were to do this again, we'd probably do some more measurements beforehand. When I first saw this graph at last year's state conference, he put it up there, and I looked at it and said, well, where's the post-install line? You can actually see it up the top there, that orange line. But they had to drill into it in a little bit more detail to show that it wasn't quite meeting 100%, although 99.99 is pretty close. Just a little bit more detail there. Essentially, that tells us that while it's very good at point of use, we still have some downstream contamination that we still need to deal with. I'll jump through dew point. We got some data off BOM. Dew point has been increasing over the last 50 years, absolutely. Generally, it's linked to the temperature of the oceans, so there is a direct link there, and a guy in BOM will tell me all about it. That's the effect of dew point. On the left there, that's a brand new building, not even moved into yet, and we got dew point forming on the supply register. You leave it long enough and it'll end up like the one on the right-hand side. I'll just jump over a couple of these because I know we're out of time. We did some monitoring at Royal Brisbane Women's Hospital around dehumidification. So we had some wards that were set up, others that weren't, and we got some really good data sets through that, essentially demonstrating that dehum does work and it works well. I can probably leave it at that. Thank you.